Okay, we are on practice test 3, our last one, and we are going to get it done, hopefully. Our test is Friday, whether we get this done or not, so let's hopefully get it done. We started it a couple days ago, so we did the substitution and the elimination problem already. Those, remember, your test is going to look just like this, okay? Those problems, substitution, elimination, you've been doing for years and years. So hopefully you don't have any issues with that, but there's all this practice if you do.
Wait, you said on the test it will tell us when to do right?
The test looks exactly like this, okay? So we're practicing exactly what's on the test. So now we've got a Kramer's rule problem. Now this one is new. I think that's a 1. I got some marks on my paper. All right, I'm going to use Kramer's rule to solve this. Okay, so the first thing I do is make a determinant of the coefficients in the problem. So here are my x coefficients all lined up. Here are my y coefficients all lined up. And now I'm going to evaluate that determinant. So I'm going to multiply down, that gives me 10. I'm going to multiply up, that gives me -3. And then I'm going to subtract those numbers, so I get 13. That means that the answer to the question, which is going to be an ordered pair, like 5, 6, just like it is with substitution and elimination.
I can't hear you.
Oh, sorry, that's because I turned it off again. I'm going to get substitution and eliminate, the same kind of answer I get when I substitute and eliminate. I'm going to get an ordered pair. Both of my answers will be fractions whose denominator is 13. So this determinant gives me the denominators for my x and y answers. Now I got to find the numerators, the tops of these fractions. And I find those by plugging in the 7 and the 1. So I'm going to make another determinant for x, another one of these. But instead of having the original x numbers, I'm going to paste these on top. So I'm going to have 7 and 1, and then -1 and 5. And then when I do y, same thing, only I'll paste these on the y column. So I have my 2 and my 3, and then my 7 and my 1. So when I'm finding the numerators of my individual letters, x and y, these two numbers replace that column. So if I'm solving for x, this goes here. If I'm solving for y, this goes here. And then I will evaluate those determinants just like I did this one. So multiplying down gives me 35. Multiplying up gives me -1. When I subtract, I get 36. And that is the numerator of that fraction. Same thing here. Multiplying down gives me 2. Up gives me 21. And when I subtract, I get -19. So the answer to the question is right there. So that's how we do Kramer's rule. Okay? Now, the next page of our test is just a whole bunch of matrix arithmetic. We know that sometimes stuff's not possible, right? So we might get no solution to some of these. Let's look at the first one. The first one tells me to multiply matrix A times matrix D. Matrix A I know if this is even possible? What do I need to do to see if it's possible?
Don't you write out like 3 and 2, and then 3 and 3, and then you connect the middle ones if they're the same number as possible.
Exactly.
They're not possible.
Right. But you gotta get your dimensions right.
Yes.
How many rows does this have?
3.
How many rows
Two.
does this have? 2 rows, 3 columns. This one has how many rows?
3.
How many columns?
3.
3. So these two are multipliable, because in order to multiply, the middle dimensions have to match. And the outside dimensions tell me how big my answer is. So this is going to be another 2 by 3. This one's going to be the same size as my first one here. It's going to be a 2 by 3. To fill in these numbers, that's what you have to find, is all these numbers. Pick a spot. I'll just pick this one. It's in the first row and the first column. So rows, columns. So I am going to take my first row, which is 1, 2, -1. And I am going to multiply it by my first column, which is 1, 3, 0. And then I'll multiply each of those pairs and add them up. So 1 and 6, so that looks like it's going to be 7. Because it's 1 plus 6 plus 0. Now, what's going to change when I move over here? Now I'm going to use the second column. This is still the first row, so I'm still using 1, 2, -1. But now I'm going to use the second column, which is 2, 2, 1. So then I multiply each pair and add them up. I think it's 5, isn't it 5? And then finally, I need this spot, which is still in the first row, so I'm still using 1, 2, -1. But now I'm going to use my last column, my third column. Is that -1? Okay, now what happens? Now I go to the second row, because now I'm looking for this number right here. It's in the second row, so now I'm going to be using 0, 3, 4. And I'm back to the first column, so 1, 3, 0. Remember, when you multiply by 0, you get 0, so I think that's just 9. And then still the second row. Now the second column. Let's see. 10. And finally the second row, third column. Oh gosh, is that 11? And that's how we multiply. Now the next one isn't multiply. The next one is add. So the rule for add is different. Look at matrix C. What are the dimensions of matrix C? 2 by 2. What are the dimensions of matrix A? 2 by 3. Can we add C and A together? No. So B is a no solution. Impossible, can't do. Remember, when you add, you have to have exactly the same size matrix. And we don't. All right. Now, what about C? Am I gonna be able to do 2B minus 3C? I think I am. Because B is a 2 by 2, and C is a 2 by 2. So I've got a little arithmetic to do, but this is a doable problem. Would everybody agree? So I'm going to take 2 times this one. So 2 times everything. 3 times this one. Now I'm going to be subtracting. So if that minus sign is bothering you, just cover it up for a minute. We're going to be subtracting. And then 3 times everything. And now we're going to do the subtraction. So negative 2 minus negative 6. Negative 2 minus negative 6. That's going to give me a 4. 4 minus 6. 6 minus 15. 2 minus 3. When you add and subtract, you have to be the same size. So that's why we could do that problem. Please tell me this is running.
It is.
All right, so now we're going to find the inverse of B. This is a 2-step process. Does anybody remember either step or both? Yes, Princess.
Where you find the determinant that
Got it.
you like switch it around.
Yep, so we got to find the determinant and then start switching around that matrix. So the determinant, we already did a couple of them. We multiply down, get negative 1. Multiply up, get 6. So when I subtract, I'll get negative 7. Negative 1 minus 6. Now, don't do anything with that just yet. Now we're going to take the numbers in this matrix and we're going to start messing with them. So remember these 2 switch places? Everybody remember that? So we got 1 and negative 1. And then these change signs. So it's kind of random the way we do it, but those are the rules, and so we just do it. So we switch these 2, change the signs on those 2. Now, we take each of these new numbers here that we've got, and we divide them by negative 7. And then we simplify anything that simplifies. So that's just negative 1/7. This would be positive 2/7, positive 3/7, and positive 1/7. So that is the final answer. Nate, you with us? Gabe?
Wait, wouldn't the negative 1 be on, like in your final answer? Can't you switch the negative with positive 1?
I switched places, so they were over here. So this was a positive 1, and this was a negative 1.
Oh, is that your final?
But then I divided by negative 7, so that became negative,
Yeah, I see.
that became positive. All right, negative 2b. Can I do that? Can I take negative 2 times b?
Yeah.
Yeah, you can take negative 2 times anything. You just distribute it, right? So negative 2b would be 2, negative 4, negative 6, negative 2. That's easy, right? All right, what about F? Can't do it. Why can't we do it?
The dimensions.
The dimensions don't match up, right? B is a 2 by 2, and D is a 3 by 3, and these don't match. So they cannot be multiplied. Don't be alarmed on your test if there are some cannot do's. We've had them on every practice test. All right, what am I doing here?
Copy the first two columns.
Yep, I'm gonna copy the first two, I'm gonna evaluate this determinant, that's what this is called, I'm evaluating the determinant. But you're gonna take the first two columns, so 1, 0, 4, negative 1, 3, negative 2, and you're just gonna recopy them in that order, right next to the problem. All right? Then we multiply down, and notice we always start here with our multiplication, every time. So we multiply down and get 9, multiply down again and get negative 4, and multiply down again and get 0. All right, then we multiply up and get 24, up and get negative 2, and up and get 0. All right, what do I do with this mess? I've done a bunch of multiplying. What do I need to do? Well, I need to total all that up, and I get 5. And I'll total all this up, and I'll get 22. So these are the downs, down, 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 added up to 5, up, 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 added up to 22. And then what do I do with those two numbers?
Subtract.
Always subtract downs minus ups. So the answer to the problem would be negative 17. Okay? Now I'm gonna hand out a few things. I wanted to get this stuff in your hand. I forgot to teach you. So while I am handing this out, would you work on the next section, which is your vocabulary section? We have had a vocabulary section on every practice test. So you need to, yeah, I'm also giving back some old papers for those of you who have some. I'm giving you some stuff for chapter 9. So everybody will have it. I hope we can go back and get some of 6. But I don't know. Our days are running out. Okay, everybody should have gotten 2 packets from me. Did everybody get 2? Perfect. All right, how far did you get with your vocabulary? Is B a square matrix? No, why not? Don't have the same dimensions. To be square, you gotta have the same number of rows and columns. What does B sub 2, 3 mean? Negative 2. It's the entry that is in the second row, third column. So second row, third column, that would be negative 2. What are the dimensions of B? 3 by 4. 1, 2, 3. What's a scalar? What do we mean by scalar? Okay, so instead of saying a thing in front of that, maybe we would say a number that multiplies the matrix, right? a thing before that, it's a number that multiplies the matrix.
Would you accept the coefficient?
I would, you said coefficient, absolutely. And then define matrix, a rectangular array of numbers arranged in rows and columns, right? And if you didn't get that down, look back at practice test 2, practice test 1, and your notes, because it's been in all those different places. Okay, now we are ready to do our word problem. Okay, let's look at it and see what we've got. Okay, so some of my vertical lines in my chart didn't come out very well, but you know what, you know they're there, so. Here we go. So we've got questions A or type B, and we got total, we got number, we got fixed interval, and we have value. And we're gonna maximize something, and our constraints. All right, you're about to take a test that contains questions of type A worth 10 points and B worth 25 points. So the value of the questions is 10 and 25. You must do at least 3 questions of type A, but time restricts doing more than 12. What does that mean? The A's have to be between 3 and 12. So that's your fixed interval. I'm going to use X and Y for the number of A questions and the number of B questions, but you can use A and B. You don't have to use X and Y. You can use A and B if that helps you keep track of it better. But whatever the A's are, they have to be between 3 and 12. What about the B's? They have to be between 4 and 15. Oops. In total, you can do no more than 20 questions. Where's that go? 20. That's the total number of questions that you can do, right? Now read through the problem. Is every single number in the problem in the chart? Yeah, they're all there. So these are fine. I'm not worried about it. There's nothing written there. There's nothing to write there. The purpose of the chart is only to organize your information. Okay? Now, based on that, you have to tell me, what are we trying to maximize? What do we want to get the highest of? Score. So we're going to maximize our score. And how is our score calculated? 10x plus 25y. That's how we calculate our score. Now, what are the constraints? In other words, what are the things I'm going to be graphing over here to help me figure out the answer to the question? X plus y is less than or equal to 20. The question, or the problem itself clearly states you can do no more than 20. So that means however many of these you do, they have to add up to be less than or equal to 20. Always, if you have fixed intervals, always graph those. And we're always going to write down y is greater than 0, greater than or equal to 0, and x is greater than or equal to 0. Right? All right. Now we're ready to actually start graphing. So here we go. This guy right here. Oh, wait a second. I can do 20. You're gonna have to extend your grid a little bit. Or you can change your scale. I don't think I'm gonna change it. I'm gonna go ahead and do 20. So if I cover up Y, X is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. There it is. And then the same thing, if I cover up X, Y is 20. And I'll connect those dots with a nice straight line. And where would that be shaded? Underneath, right? Down here? Feel free to bring colored pencils and do it in colored pencil. You don't have to, but it kind of helps sometimes. All right, now this fixed interval. Notice that these fixed intervals do not have 2 letters. They only have 1. So on the x-axis, I'm going to graph those 2 points. This is an x problem, so I'm going to mark 3, and I'm going to mark 12. And then how do I handle that? Who remembers? How do I handle that? Vertical lines, straight up. So straight up from here, straight up from here. And where would the purple be shaded? Remember, X has to be between 3 and 12. So aren't you shading in between? So we are between the purples and under the red. So right now we're kind of looking at this space right here. Now we're going to throw these in on top of that. So here we go. Y is 4. Again, 1 letter. So on my Y, 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And these are going to go straight across this way. Would you agree with me? And green would be shaded in between. You have to be in between your green bars. So think about what you've got shaded. You probably have a good shade going there. If you are between the purple and between the green and under the red, aren't your corners of your shaded area these right here? Is that what your shaded area looks like? Under the red, between the purple, between the green. Now, some of these points are incredibly easy to identify. This one right here is 3, 4. Would you agree with me? So one of my points is 3, 4. This one is 3, 15. This one is 12, 4. Now those are all super simple because they're where my bars are coming together. That's easy. Now this one's a little bit harder, but still pretty easy. What do you know about the X value? 12. So this X is 12. But on the red line, that point is on the red line, and on the red line, they have to add up to 20. So if we know X is 12, then Y has to be 8. Now similarly, look at this point right here. This one right here. We know that Y is 15 on that point right there. But it's on the red line. And on the red line, they have to add up to 20, so X must be 5. So that's the point 5, 15. Now remember what all those points stand for. This says that you're doing 12 A's and 8 B's. So you can calculate your score. Oh, I can't because I gave my calculator away. But, maybe I can do it in my head. What would 12, I guess I'll do this one. What's 12 and 8? What would that be? 120. Is that plus 200? Is that 320? I'm relying on you guys with the calculators to help me out here. 12 A's or 12 X's and 8 Y's. This is going to be less. This is only going to be 220. This one will be 130. And then I don't know. Yeah,
3 and 15 is 405.
405. Perfect, thank you. Are the rest of them right that I did in my head? Is that what you got? Okay, so if this is you and you're taking this test, what are you gonna do?
Put as much things down as I can.
You're gonna do 5 A questions and 15 B questions for a score of 425. So you're gonna write a sentence that kind of recaps that. I'll do 5 A's and 15 B's for a score of 425. We haven't run into any, but sometimes our fixed intervals aren't closed on both sides. What I mean is, a problem might say, instead of stating it exactly as it did here, what if it said, you have to do at least 6 A's? That's what it said, that's all it said. It said, you must do at least 6 A's. What would be that fixed interval? What does that tell you about X? X has to be greater than or equal to 6? They didn't give you an upper limit. In this problem, they gave you a lower boundary and an upper boundary, and so you graphed both lines and you're in between. Well, what if all you had was this? You're still going to graph your vertical line at 6, but there's only one of them, so where would that be shaded? To the right. And it would just be shaded to the right. I mean, as far over as you needed to go. So that's still considered an interval, even though it isn't a closed interval. It's not like bounded on both sides. So if you could, let's say you're selling hot dogs and you can't sell more than 50 hot dogs. You cannot sell more than 50 hot dogs. What do we know about X then? Less than or equal to 50. So you have your vertical bar, but now you'd shade on this side of it. Okay, one more problem, like the one you just did. And then we probably will have a minute or two to do any other last minute wrap up questions you have. I'm not going to write down the original problem, I'm just going to write down my matrix. Looks like my variables are E, F, G, and H. So 1E, 2F, negative 3G, 1H, negative H. 1, 1, negative 1, negative 1, negative 1. 2E, no F, negative 3, 4, and 2. No E, no F, G. All right. Hopefully I copied everything correctly. just did one of these, let's see if we can do another one correctly. This one's been planned probably, so, oh, I can't do it anyhow.
Four negative three, two,
4,
zero.
-3, 2, 0. Somebody else got that too? Okay, that must be the answer. So the answer is 4, -3, 2, 0. Now, if you know what you're doing and you didn't get that answer, go back and check, because the calculator does not make mistakes. The only way you can be wrong is if you put in a number wrong. So make sure you've got zeros in the right spots and negatives and everything else. Okay, 3 up. Lindsay,